An octopus the size of a tennis ball is carrying something it cannot use yet. That is the whole mystery. North Sulawesi, Indonesia. Shallow tropical water, 5 meters deep. The seafloor is pale sand and scattered coral rubble. Shafts of surface light cutting down at an angle. The water is warm and clear. Across this open, featureless flat, something small is walking. Not crawling. Walking. 2 arms extended like stilts. The rest of its body lifted awkwardly off the sediment. Slow. Exposed. Nowhere near any rock or shelter. Pressed beneath its body, 2 halves of a coconut shell. Julian Finn, a researcher at Museum Victoria in Melbourne, spent 3 years filming in Bali and Sulawesi between 2005 and 2008. He had documented unusual octopus behavior before. But this stopped him. His words from the Museum Victoria press release in December 2009. I could tell that the octopus, busy manipulating objects, was up to something, but I never expected it would pick up the shell and run away with it. The species is Amphioctopus marginatus, formally described in 1999, common name. The coconut octopus, body the size of a golf ball. Arms spanning 20 centimeters. Not large, not fast, and when carrying those shells, not hidden. It's only camouflage, the chromatophores firing in small amber waves across its skin, cannot compensate for what it is holding. The shells are not being used for anything right now. There is no predator visible. No shelter needed. The animal is simply transporting them towards somewhere that does not yet exist. That is the question Finn brought back to the surface. What does it mean to carry something useless? What does it mean to plan? In December 2009, Current Biology published Finn, Tregenza and Norman's paper, Defensive Tool Use in a Coconut-Carrying Octopus. A single published document. 1 filmed behavior. And a neurological question the paper raised, still unanswered, that forces a rethinking of where intelligence actually lives. That question is where this record is going. For decades, the definition held. Tool use required an animal to manipulate a detached external object, direct it toward a specific goal, and do so deliberately, clean, airtight. And by consensus, it was a vertebrate thing. Chimpanzees probing termite mounds with stripped sticks. Crows bending wire into hooks. Sea otters cracking shellfish on rocks balanced against their chests. The examples were all warm-blooded, all centrally brained. The pattern seemed to mean something. The assumption behind the definition was architectural. Vertebrate brains have a centralized command structure. Cortical regions plan. Subcortical regions execute. Tool use, researchers believed, required that hierarchy. An invertebrate nervous system, distributed and decentralized, simply could not coordinate that kind of deliberate, future-oriented behavior. That was the consensus entering 2009. Then Julian Finn's footage arrived. Finn had spent 3 years underwater in Bali and North Sulawesi, filming between 2005 and 2008. What he documented did not bend the definition. It walked straight through every clause of it. Object external. Manipulation deliberate. Goal protection. Each box checked. But the footage created a problem nobody had anticipated. The octopus was not using the shell when it carried it. The shell was useless mid-transit, awkward to hold, slowing the animal down, exposing it to predators. This was not tool use. This was something harder. Mark Norman put it plainly in National Geographic News on December 14, 2009. The octopus must have some kind of foresight that it will need the shells in the future. Foresight. In an animal with 2/3 of its neurons distributed across 8 semi-autonomous arms, each arm capable of independent decision-making. No centralized cortex issuing orders. The footage did not blur the cognitive boundary between vertebrates and invertebrates. It forced researchers to ask a different question entirely. What exactly was happening inside an animal that accepted a cost it could not yet spend? Here is where the mystery lands. Not in the behavior itself. The carrying, the stilt walk, the shells pressed beneath a body the size of a tennis ball crossing open sand in North Sulawesi. That part is filmed. That part is confirmed. The mystery lives in the 2009 Current Biology paper by Julian Finn, Tom Tregenza, and Mark Norman. Not in what they proved. In what they named and then could not answer. Finn watched this animal carry shell halves up to 20 meters across open seafloor. Slow, exposed, vulnerable. The shells had no use yet. The animal accepted real cost right now for a benefit that did not yet exist. That is the formal definition of prospective cognition. Planning. Finn's paper confirmed it was the first documented case in any invertebrate on record. As Finn told the BBC on December 14, 2009, they're carrying these shells for considerable distances to use later on. Not instinct, not reflex, a deferred transaction. But the paper also filed the question it could not close. 2/3 of an octopus's neurons do not live in its central brain. They live in its arms. Each arm carries its own dense nerve cord. Each arm processes, adjusts, decides, semi-independently, without instruction from the center. Roger Hanlon at the Marine Biological Laboratory documented this distributed architecture across years of cephalopod research. Jennifer Mather at the University of Lethbridge built the framework for asking what cognition even means in a nervous system with no headquarters. So where does the plan live? Which part of this animal decided, before the shelter existed, before the threat appeared, that these shells were worth carrying? The 2009 paper named that gap precisely. Published it. Left it open. What the index concludes, a creature without a central brain demonstrated planning, and science has not yet located where inside it the future is stored.